Right, Kanalaha, we are live on LinkedIn and YouTube.
Thank you, Kazal. Let's wait for people to join and then we will start. Let's wait for some time.
Yes.
Okay, we still are not visible on LinkedIn. Let's just wait.
I think now we are live.
Yeah, awesome. So we'll wait for people to join. Hi, good evening, everyone. We're just waiting for 2 minutes. Let's wait for everyone to join and we'll start straight away with today's proceedings, which is domain 3, 4, and 5. Right. People are still joining. People are joining right now. Hi, good evening. Good evening, Ian. Good evening, Rahul. So I hope we get all the people who were there yesterday, almost 50 people on LinkedIn and 50 people on YouTube. That's a huge audience. So let's wait for some time and we'll start today's proceedings with some core concepts of CISSP which do matter and do come in the exam. Right. I'm waiting for more people to join. Right. Let's wait for some more time. Well, let's have a feedback till such time when people join. How was the session yesterday? Any feedbacks you will like to give? Anything which we can improve upon? Uh, do you think it's a difficult thing to capture or difficult thing to understand CISSP? Understand that CISSP is a base forming certification for information security. It's not an advanced certification, though people take it as an advanced certification. Is actually a base forming certification, right? And then you can master your skills towards any domain you would like to. Those of you who are pretty experienced, they can capture all the information from different domains. Maybe you have worked there, maybe you have not worked there, and start assimilating it in your career opportunities or career lines. Okay, so we will start now, and I waited for 5 minutes. We start with domain 3. Okay, so what is domain 3 about? Domain 3 is about security architecture and engineering. So what are the core things that uh, you know domain 3 covers? Domain 3 covers majorly around 13 to 15% of the exam. Cryptography is a major portion of, and understanding cryptography at a very high level. What is asymmetric, what is symmetric, what are the key algorithms today which are working, what are the concerns because of quantum computing, whether today's algorithms will stand the test of time with quantum computing coming into space, because we'll be able to brute force today's algorithms in the times to come, right? And then we look at systems, secure system design. Whenever we develop systems, what are the considerations for understanding how a system is designed securely? What are the concerns you need to have as an information security officer once you are developing a system or procuring a system or taking a SaaS platform into your organization? So these are the concerns which you will look into, which you will ask. And believe me, I consult with very large organizations as VC. So, and these core fundamentals is what keeps me going once I deliver CISO engagements with a lot of organizations in fintech, abroad, in US, in Middle East. So these core fundamentals keeps me going very strong. Solutions I can build. It's not difficult to build solutions. You can get a vendor, you can get a system integrator to build a solution, right? But what makes it important is to understand the baseline, and that's what domain 3 talks about. So Domain 3 starts with you know first concept of access control models, right? So yesterday we saw that we have, once there is a subject which wants to access the information, which is an object. Subject is always, active in nature, and objects are always passive in a given circumstances. A subject could be an application which is trying to access another application. At that point in time, the application which is being accessed is actually passive in nature. It cannot be in dynamic state. You cannot access something which is in dynamic state. And what whenever we build access control models, we basically are implementing confidentiality, integrity, and availability principles on a given subject object relationship. And these subject object relationships give rise to identification, authentication, and authorization. And you build these things based on certain access control models, which are well understood models which have developed over a period of time, right? So what are those models? Those models is, first is called a Bell LaPadula model. Bell LaPadula model is a very famous model which was developed during 1970s by US Department of Defense. It talks about hierarchical access control. That means if this is a secret level of data classification, I am at confidential and say this is public, right? So if I'm here, I should not be allowed to access information up. I can uh, I can probably write information here, but I cannot read information here, because if I read information here, I have the capability to write it here, which will make the information go below its security classification. And Bella Padula, that's why deals with something called protecting the confidentiality of information. It's got three rules: no read up, no write down, or last is the mandatory access control, that is, you remain within your silos. Similarly, BIBA model is to protect the integrity of information. And what happens is, same concept of three levels. This is secret, this is confidential, this is restricted or public. If I'm at this level, I should not be allowed to read any information down. Why? Because if I read information below my security classification, I might corrupt my information in my level, right? That's a challenge. So we need to interpret these models based on the situation and circumstances. And when we develop systems, systems do not engage one model. There are multiple models. There are times when an operating system will operate in a very, very siloed, uh, you know, uh, operation. And at that time, probably the system engineers or designers have implemented a Bell LaPadula model. Okay. Uh, in certain circumstances, operating system would like to have a model where there could be no integrity violation. So there you will deploy a BIPA model, right? Then you have something called Clark-Wilson model. Clark-Wilson model uh, is based on two very fundamental issues. One is called well-formed transactions and separation of duties, and there is integrity also. I'll give you a very, very good example of what is Clark-Wilson model. You access your banking applications, right? Now, if you log into your banking application, you can see your balance. It's not a very, very restricted information. If I get your username, I get your password, and I request you for your MFA, I might see your balance. Looking at balance doesn't make me do something. But what if I've got your credentials and now I want to do a transaction? Now, if I want to do a transaction, I have to elevate my privileges. There is a clear cut separation of duties. So if you would have done a banking transaction ever, you would have seen that to add a beneficiary and then wait for 24 hours, which is called the integrity verification process, where I've added a beneficiary and then I'm waiting for the beneficiary to be approved after 24 hours, then only I can make a transaction, is a beautiful example of the Clark-Wilson model. Clark-Wilson model, it is implemented in financial transactions in a very, very restrictive environments where you have to elevate your privileges to do a transaction. Okay, that's the Clark-Wilson model. Then you have something called the Brewer-Nash model. Brewer-Nash model deals with something called whenever there is a conflict of interest. Okay, say our operating system is executing a process. Okay, and this process has access to some class of information. Okay, and if at the same time it gets an access to another class of information which might hinder the integrity of this process, such access will not be allowed. Right? So Brioche model creates a Chinese wall, okay, around a process so that a given process cannot interfere with uh, another process which might lead to conflict class, information of conflict class. You can also look at a physical example. Say I have a chartered accountant who is aware of, he's a third party chartered accountant. He's aware of a company which is uh, going to, do a merger and acquisition with company X, right? So can I also be the chartered accountant of this X company? I cannot. I will not allow, as a CFO, I will not allow this chartered accountant to become a consulting chartered accountant for a company X, which this company is going to acquire, because there would be conflict class information. Therefore, I'll create a Chinese wall around this particular information class. Right. So that's called Brewer-Nash model. And whenever we do access control model, we design access control model, we keep into consideration certain core design principles such as least privilege, fail safe. Whenever we systems are designed, they are designed for fail safe defaults. That is, if systems fail, they go into some kind of basic security. Windows blue screen of death, fail safe. If I'm failing, I go into a safe mode so that I don't get exposed. Economy of mechanism. Whenever we implement security controls, there have to be very very strict economy of mechanism. You cannot protect everything with same class of access control. Somewhere you need to reduce access control mechanism, somewhere you need to increase based on the kind of information you are handling. So these are some core design principles of systems. Now when we look at cryptography, we look at cryptography uh, in today's internet or the digital systems. Actually the complete internet is working because of two major operations, which are symmetric key operations and asymmetric key operations. To understand very simply, symmetric key operations is, this is a lock, I open it with, I lock it with this key, and I open it with the same key. Okay, I need the same key to do the locking operation, that is the encryption operation, and I use the same key for decryption operation. Right? So if this is Alex and this is Bob and they want to communicate, right, the key will be same. Now tell me one thing, if Alex generates a key, the problem is, how does it transmit the key to Bob? Okay, that's a problem statement for symmetric key operations, because the same key is required. It's like you locking the door. You and your wife are moving out of the house. Your wife is working in office. You lock the door. Now, how do you ensure that this key reaches your wife safely? Or she might have to carry a duplicate key. And that's the problem statement in symmetric key operations. You have to have a duplicate key. Both need to have a same key. Who has the custody of the key? Who gives the key to Bob and Alex? So there are two major problems with symmetric key operations. Can you name them on the chat? The first problem statement is dash. Second problem statement is dash. Let's see. A wild guess. I've given you the problem. Can you identify what is the problem with symmetric key operations? It'll wait for the answers quickly. So what happens when number of keys increase? Amit, Major Amit Kumar. What happens when number of keys increase? So Tuhin somewhere got the answer. How do I share the key? How do I share the key between Alex and Bob? So there needs to be a key distribution mechanism. So distribution is first challenge. Okay. So somebody has identified security. Somebody said distribution is a major challenge. Out of band sharing. I have to share it out of band. Very right. Right. Transportation. So all comes under distribution. Distribution is a major challenge with symmetric key. What is the second problem? You have somebody has identified the number of keys increase exponentially. Number of keys. So there's a very simple formula, n into n minus 1 divided by 2. So that means in symmetric key cryptography, if say number of users is 100, that means there is Alex here, Bob here, Max here, Devdutt here, Ian here, Shubhajit here. So there are 100 people in a given, you know, in a given set, distributed geographically. So the total number of keys which would be required for each one of them to communicate in a very, very secure manner is going to be n into n minus 1 by 2. That is equal to 100 into 100 minus 1 by 2, which would be around 9900. 9900 divided by 2, 4450. Imagine 100 people will need 4450 keys. Who is going to, and each person is going to have 99 keys. How do you secure these 99 keys? With, say, I'm Alex, and this is the challenge in the symmetric key cryptography. Now, erstwhile, we were in the army. Those of you who are from the armed forces, they know very well what was the problem statement in distributing. We used to carry it with weapons, symmetric key. So we would carry in 3 boxes, chained, locked. In a train, there was a separate compartment which was booked. Nobody was allowed to go there. We used to travel in first class compartments, and it was chained, locked with weapons, not allowed to sleep. That was the kind of security which was required for exchanging symmetric key cryptography. And look at internet, which is a public network. How do you share these symmetric keys? You will require something called a KDC, key distribution center, and that's actually a problem statement in the internet, on the internet, right? Yeah, Amit, very right. Cipher was a huge pain for us to manage cipher, right? And that's a World War II concept. All armies, all organizations, and we are not talking anything secret, right? Even the best of class, uh, you know uh, security based organizations will have cipher, right? And in the corporate world today, we address that thing by saying, oh, we need a KDC. Okay, someone who will manage these private keys. Very difficult. So to solve this problem, uh, three scientists came together and introduced public key cryptography. Rivest, Shamir, Alderman, RSA, the most famous mathematicians in the cryptography space. I've been a chemistry student where I had math, so we used to study their algorithms very well, right? So RSA, Rivest, Shamir, Alderman are considered the father of cryptography as far as asymmetric key operations is concerned. The concept is very simple. Uh, every subject, Alex, will have a private key and a public key, and the public key will go to a public repo. And similarly, Bob will have a private key and a public key, and the public key will go into a repo. Can someone tell me what is a repo, generally known as? In the internet, what is the repo known as? You would have come to know of this term. Can someone tell me what is it called? A repo which holds public keys, distributes the private keys. Quickly on the chat. The right answer goes to Ian Leroy Oracle. It's called a PKI, public public key infrastructure, right? So a public key infrastructure holds your public keys, everybody's public keys who are there in the asymmetric key ecosystems. And PKIs are managed by Google, Microsoft, governments, right? The internet IANA manages major PKIs. So today, once your browser speaks to a server, its PKI, its digital certificate is maintained by its authentication is maintained by Google's PKI or Microsoft PKI. Okay, and how does it happen? Right, it happens if you try to understand. I'll try to make this understand quickly. Alex wants to send a message M, which is encrypted, to Bob. Right, that's the problem statement. What Alex does is Alex picks up Bob's public key. Okay, puts Bob public key to encrypt this message. Okay, so it encrypts it using Bob's public key, and therefore the message is encrypted E and is sent to Bob. Bob can now use his private key to do the decryption operation and get the message back. So whenever you want to send a message, you take their public key and use it because you have access to their public key. You can encrypt it, send it. Because Bob have access to his private key, only his private key can open the message. That's the asymmetry between the keys, right? So if now Bob wants to send a encrypted message to Alex, which key will Bob use? That's the question. So that it reaches only to Alex and no one else. Only Alex can open it. And remember that I can pull the public key from the repo, which is the PKI. Right. So Ian answered it correctly. He's going to use Alex's public key, a receiver's public key, as Devdutt says, Alex public key. Right, great. Now, the problem statement is here the number of keys required is only 2n. That means if there are 100 people, how many keys do you require? Just 200 keys. Compared to symmetric key cryptographic operations where you needed 4,450 keys, right? That's the problem. But there's one problem in this asymmetric key operations. If there are 100 people in this ecosystem, and this is your PKI, when Alex sends a message to Bob, anybody can send a message to Bob and pretend to be Alex. Just on the email, I'll say, hey, listen, I'm Alex, I'm sending you a message. That means there is a problem of non repudiation. Bob cannot identify who has actually sent him the message, right? That's a major challenge in asymmetric key operations. And what solution comes to rescue in asymmetric key operations to ensure that non repudiation does not happen? That's the question. What is the solution required to establish non repudiation in asymmetric key operations? Once you answer that, I'll explain how. Again, I will not waste time. Ian, you have you have answered it correctly. Mohan, you've answered it correctly. We need a digital signature. So, what is the digital signature process, right? I'll explain to you very quickly. So, what happens is Alex wants to send a message M to Bob. He encrypts it. He encrypts it, and now he has an encrypted message. He uses Bob's public key. for this operation, right? But he now needs to put his signature. So what he does is he takes a something called a hash of the message. Hash is something called a non, you know, it's a one-way function. So it's a metadata. So once you hash it, you get a unique sequence of that message. Okay, say XCCDF. Any changes in this message will change this hash, right? We all know what hashes are. So what you do is you take this unique hash and now encrypt it with your private key. So once you encrypt it with your private key, what you get is an encrypted hash, EH. And now you send both to the receiver, that is Bob. Bob takes the EM, puts his private key, and he gets the encrypted the message back. But he still doesn't know, but he's still not sure whether this message has come from Alex or not. For that, he takes the encrypted hash, and now because I've said that it's come from Alex, I pull Alex's public key. I pull Alex's public key, put Alex's public key, and now I get the hash. So now I'm assured that it has come from Alex. But one last step is required. Has the message gone through any changes? So I carry out a hash. And if this hash and this hash are equal, two things are, three things are: confidentiality is ensured, integrity is ensured, non-repudiation is ensured, right? And this process happens with many libraries which developers put behind their applications to achieve confidentiality, integrity, and non-repudiation. So that's all about symmetric, asymmetric, and digital signatures, right? So what happens is we need to understand these concepts to understand cryptographic operations in uh, you know for as far as CISSP is concerned. That's broadly is what is asked, right? Also, you need to know some key algorithms like AES. AES is one of the most 99.99% of algorithms today on the internet run on AES. All major operations happen because of AES, because AES is still considered secure even against brute forcing attacks. Now, once cryptographic is done, next thing comes is what are the secure architecture concepts, right? The first secure architecture concept in system is something called trust levels, right? How do you design systems with different levels of trust? Okay. And that concept is called a TCB, trusted computing base, right? So trusted computing base, what it does is it creates something called a very, very secure or a base of a system, which if compromised, you lose trust in the system. Can someone tell me in your computer system, a laptop which you use, what is your trusted computing base, which gets, which if compromised, exposes your system, takes your trust away? What is that core of your system called? Just discuss your laptop or mobile phone, whatever. What if compromised, you will lose trust in the system? Really? Rahul, a firewall is okay. TPM. Firewall is an ancillary application. Anybody can get an access to it. What if compromised? If firewall is compromised, I can reconfigure it. If TPM is compromised, yes, maybe because all the keys are there. Therefore, TPM would be part of the TCB, right? So, what is that major component? Which so TPM compromised means what is compromised? The kernel is compromised of the operating system's kernel has been if somebody is able to compromise your TPM, there are two only possibilities. Either somebody has physically opened your machine and has taken off, okay, or somebody has been able to infect your kernel or got privileged access. Once somebody is able to infect or expose the core components of your kernel, that means you are not ready to trust that system. Rootkits, if your computer gets infected by rootkits, okay, those who have been in security for quite some time, there were times when rootkits are there, you would say just throw off this laptop because your kernel is compromised. That means your firmware is compromised. That means boot sectors are compromised. We can't trust the system anymore, right? So it's not the microprocessor. Microprocessor has probably microprocessor just processes it. Okay, so it's the kernel. If your kernel is compromised, and therefore for an operating system, TCB, you will say the kernel is the TCB. So TCB is that core of the system which is compromised. You don't trust the system, right? Virtualization. Today, most of the systems today work on virtualization. Most of the operating systems, most of the systems work on virtualization, where your hardware layer, also known as the data plane, is separated from operating system and software applications and drivers through a very, very strict layer, which is called the hypervisor, also known as the virtualization layer. Okay, so that your core of the system is not compromised. There's someone sitting in between non-trusted applications and the trusted layer. If your hardware is compromised, somewhere down the line everything is compromised. Therefore, operating systems incorporate a lot of virtualization to achieve security of the underlying TCB. So virtualization is one of the ways. Cloud models. Today, we depend completely on cloud models. We take infrastructure as a service, platform as a service, software as a service, right? And there we have the concept of something called shared responsibility. So security is all about shared responsibility, and in cloud, it's very, very visible because the data center, the physical security of the data center, the availability of the data center, the underlying hardware infrastructure is the responsibility of the cloud service provider, and the user has their own responsibility, configuration management, security management of applications, and the underlying virtual servers, serverless applications will come on the head of the user, and that's called the shared responsibility model. Right. And when you design systems, next thing is something called side channel attacks. Right. What are side channel attacks? A side channel attacks is you are aware of the system working, where the information transfer is happening from point A to point B in a siloed atmosphere. Side channel attacks means, can I take the information out through any kind of a channel which somebody is not aware of? A simple example could be, in most of the techniques when we do exploitation, we deliver a malware in such a way that we can create a VPN so that we can do a side channel attack. Attackers create this kind of a VPN architecture. Why? In most of the organizations, VPNs are not monitored. So attackers say, okay, VPN, since VPNs are not monitored, can I create a side channel through a VPN? Right? A simple example. Therefore, a lot of organizations today have implemented controls where unauthorized VPNs are just not allowed. You monitor your VPNs very, very strictly. And something related to side channel attacks is called a covert channel. I, as an attacker, I would always like to lie low and create a channel which nobody is observing, right? So that I can steal the information from those back doors. Covert channels are back doors. There are two kinds of back doors. One is called a timing backdoor, and one is called a storage backdoor. I create some kind of storage in your environment where you are not observing, nobody is observing. I start placing information there and steal it from there when it's night time or holiday season. Timing channel, I try to find a timing error in your network so that you're not aware that I'm stealing information from a particular time slot, right? So that's called timing channel attacks. And finally, it's very important to secure your systems physically. And some of the key concepts in security in physical is something called crime prevention through environmental design. You create your environment in such a manner that it provides you inherent security. Like we used to discuss, inherent security in armed forces. When we were deploying in the army, in the armed forces, we would if you are deploying in a particular given location, we will keep, are there any natural obstacles which can help protect against naturally from the enemy? So can we design our environment in such a manner that it provides some natural cover, some kind of a natural, by using natural obstacles, right? Physical security, physical controls are always layered. Whenever you enter a building, there will be layers of physically. There will be security fence, there will be a security guard, there will be capability to observe and detect any kind of unauthorized movement, right? We also deploy a lot of physical devices, bollards, man traps. Why? Because for stopping human beings, you need physical blockades so that human beings cannot, uh, you know, uh, get across those controls. Now, the problem with these devices are they go bad go faulty after certain times, and there will be security outage. Also, for keeping environmental control, we use a lot of HVAC, air conditioning, and humidity control. And fire is one of the major concerns when we are looking at physical security. And in digital security, we come across places where it could be fire hazards. Our data centers, our server clusters, they do there have been times where server clusters have caught fire if there have not been proper HVAC, proper electricity provision, right? And also in certain secure places, we carry out a lot of electromagnetic shielding, because a lot of emanations happen from cables, and that can be intercepted. So in certain secure environments like armed forces or space exploration and other places where very very typical research happens, there we have Faraday cages where there could be no emissions. So these are the things which we probably were not aware of, and CISSP gives you an introduction to these issues, right? So this is what is covered generally in domain 3. And but yes, it's a interesting and a slightly difficult and a larger domain, right? So we have few questions, and then we will move ahead to domain 4 today. So the question is, a mandatory access control policy prevents users from reading data at a higher classification level. Which security model does this best describe? So BIBA is an integrity model. I'm trying to protect unauthorized access. That means it has to be, I'm trying to protect confidentiality. So BIBA is out straight away. Clark Wilson model is going through integrity verification process, well formed transactions. So Clark Wilson is also out. Brewer Nash model builds a siloed environment, Chinese wall. So BIBA is the Bella Padula is the confidentiality model which we use for protecting confidentiality, right? Okay. Separation of duties and auditing. Be very, very careful here. I gave you an example. When I was transacting, I escalated my privileges. So as a normal user, I can't do transaction, but when I have to do a transaction, I have to escalate my privileges, right? So BIBA, though is an integrity model, may not, just apply separation of duties. Bella Padula is a confidentiality model. Take grant model is a model where you take somebody permission, right? It doesn't protect integrity, it protects confidentiality. So Clark Wilson model incorporates separation of duties. I gave you a simple example. You log into your bank, bank account, you can see the, you know, balance. But if you want to do a transaction, you have to now increase your privileges. So there is a clear cut separation of duty between a normal user and a privileged user. So there's a clear cut separation of duties called Clark Wilson model, right? So these are the types of questions which will try to test your core concepts when it comes to domain 3. An interesting domain, a very very unique domain, and forms core part where people face a lot of problems if they have not dealt with operating systems and system security as such. The next becomes communication and network security. I think most of us will be the most comfortable in communication and network security, because generally everybody today in the security world comes from network background, and we are most comfortable with this. So what communication security deals with: the OSI standard, OSI layers, standard TCP/IP, how to address IP addressing. Why layer 4 is the most reliable way of establishing a connection. So TCP handles connectivity at layer 4. And what are the major attacks which happen at layer 2? That is MAC flooding, IP spoofing, and SYN flood attacks. Now, two core principles of network. What are the two core requirements from network? That's my question. Two core requirements. What are the two core requirements? Dash and dash. First is this, second is this. What cannot happen without a network? Can anything happen without a network? So if nothing can happen without a network, what is more important when it comes to network? So what will be your concerns from a security professional when it comes to network? What was the first? Now, Ian, you went wrong because you started thinking like a technician. You have to think like a security officer or a CISO. Can you scroll your Instagram if there is no network? Somebody said connection and security of network. Can you be more generic? In CISSP, be very, very high level. Don't be a technical guy. Connectivity and reliability. Can you put it in one word? What is the most important part when it comes to network? If I switch off your mobile tower and you have no network, is security more important, or dash of the network is more important? Pranav, very correct. Availability. If network is not available, nothing is going to work. If network is not available, nothing is going to work. Security is of no use if network is not available only. So availability is one of the most important. You will be able to access a network only if it is available. Rahul, accessibility will come only once there is network available. If there is no network, how will I? So whenever you do network engineering, network security, you're looking at that the network is always available. So if network is always available, what is the major risk? Is the second fill in the blank. Therefore, what will be a major attack on your network? If availability is one of the major requirements, then therefore, what is your major concern? What can make your network not available? What can make your network not available? Don't talk as a technician. Stability again. Fine. That is the engineering concept. Stability would come from quality of service, proper engineering, routing. What will make your network not available? Confidentiality, no. Okay, Anas, can you remove the D? You've said DDoS. It will be denial of service. And that denial of service can happen at many layers. At layer 1, what will be the denial of service? Somebody coming and cutting your cable. If I come go outside your house and cut the optical fiber cable, denial of service. If I go at layer 2 and carry out a ARP poisoning, denial of service. If I go to layer 3 and do a misconfiguration of IP or routing, denial of service, right? And network will work only up to layer 3, right? Layer 1, layer 2, and layer 3. Therefore, your major concern on network will always be denial of service. Whether at layer 1, it will be a physical risk. At layer 2, it will be a switch level layer 2 risk, ARP, and layer 3 will be a denial of service attack on your network, IP misconfigurations. Right? And balance will be your application level DDoS. They will not be network based DDoS. Okay, maybe a transport layer when you have SYN flood attacks. Right, so that's the core concept you need to understand. The rest all are technical concepts when it comes to understanding networks, right? So therefore you have multiple controls in networks. You deploy firewalls which do packet filtering. You deploy IDS and IPS. You deploy DMZ architecture. You deploy VPNs. You deploy network access control. These are the different kind of access controls on networks which you deploy to secure your networks, right? So most common, as I told you, will be the denial of service. For me, most important is network availability, and rest all come from the rest all these lead to denial of service. But a network is also vulnerable to something called man in the middle attacks. Why? Because internet today is a public network, and therefore, when Alex and Bob are transmitting over a public network, anybody can listen to it if you have not secured this network. Why? Because TCP/IP was never engineered for security. Therefore, security has to be built on top of it. And how do you build security on top of TCP/IP? That's the next question. What technology do you use to secure private communication over public channels? When you want to speak securely in private on a public channel, what is it that you use, and which has become one of the mainstay of how internet works today? Again, don't go low level, always stay high level. Correct. VPN. And you can create VPN by many technologies. You can use IPsec, you can use SSH, you can use TLS, right? You can use L2TP, right? There are many technologies which you can use to create VPNs, right? And each technology has its good part, bad part, which any technology will have, right? So therefore, we need VPNs because to protect from any man in the middle attacks. Also, networks are very prone to replay attacks. So, what is a replay attack? A replay attack is when Alex is trying to access something, and I will hear this, and then I will replay this information to get access. When servers do not implement strict access controls, right? Because they have to serve many people, right? So they may not implement strict access controls. They might take a replayed information and grant you access. And there are many ways in which replay attacks are carried out. We will not discuss it here. It's not the scope of CISSP. You need to understand a network will be vulnerable to replay attacks if you do not uh, implement controls which can secure the communication between a subject and a object, right? And then comes wireless, because wireless becomes one of the major component of today's our how we work, right? We use WPA3 as the encryption standard over enterprise you know wireless. uh, Attackers implement rogue access points in airports and in public places so that they can force you to, you know, go into a insecure network and can, you know, read your information and can exploit that. What would be one control that you would like to implement in your organization if you allow public hotspot? Right. My next question is, what control would you implement if you allow your enterprise machines to use public hotspot? Because users will do anything. So, what is one uh, mandatory control you would like to implement so that you protect your organization against any kind of rogue access points? There are two solutions which you can implement. Okay, captive portal will not allow you. Uh, Captive portal as a rogue access point, I can implement captive portals. No, see, no, MFA will not. MFA does not work at you know. It will still. I can put a. I don't want to discuss that. It's a slightly technical problem, right? No, not WPA2. NAC could be a solution, yes. Authentication, no. So the two major things is something called always on VPN. So no matter what, whenever your enterprise machine is out of your enterprise network, the VPN switches on automatically. It's called always on VPN, right? So a lot of organization, they implement always on VPN. So that, yeah, Manjeet, very correct. Great. Great to see that answer from you. I will always implement a always on VPN the moment my machine goes out of my enterprise network, right? So that the moment I'm out, the user does not have a control, right? And my VPN is always on. That is the first control, right? Any other control you would like to implement so that your users are flexible to use and they don't fall prey to any kind of and how do you push such configurations? You generally deploy mobile device management solutions, right? So you can also deploy always on VPN so that your computer, no matter what happens, connects through an organizational VPN. You can also deploy MDM. You can also deploy uh, you know something called a, not a CASB. You can deploy SaaS solutions, secure access service edge solutions like Zscaler, right? So that no matter what, no matter even if it is a insecure network entry, you can deploy a SaaS solution, but everything comes at a price, right? Then we have Bluetooth. We have used Bluetooth, and Bluetooth has had lot of issues. Generally, Bluetooth devices in your enterprises should not be enabled. One key part is to understand, software defined networking. Right now, software defined networking concept started when your local networks and WAN networks started expanding. It was very difficult to manage the hardware layer, right? So today most of the networks are software defined. There is a software layer setting which is also called the control plane, and this is the data plane, and you have applications built on top of it which can manage all the configuration, all the user requirement. Nobody has to touch the hardware layer. 20 years back, I had friends who would sit whole night and keep working with the routers manually, right? They would log into the routers, they will engineer the routers for creating VPNs and creating channels to ensure that the client network keeps working. Today, gone are those days. The hardware layer nobody touches, everybody touches the software layer applications and then configure the network. And that's called SDN. And then today we talk of concept called zero trust network, where we create trust boundaries, small trust boundaries, also called as micro segmentation within an enterprise network, so that least trusted components can be segregated from trusted components, so that there is a some kind of a segregation. And you deploy micro segmentation by achieving using zero trust architectures, for which we at times deploy intersegmentation firewalls, right? ISFWs. These are zero trust firewalls where communication is regulated between even trusted components of your network, right? So that's called micro segmentation, right? So this is broadly what we'll cover in what will be covered majorly in domain 4, that is communication and network security. Two main things whenever you're dealing with communication. Remember, availability is a major requirement. Denial of service would be a another security risk on your networks, right? So we have a question and then we will go ahead. Stable table to track the status of a network. I want to know what's happening on the network. Depending on that, I allow or disallow. I'm aware of the state. So whenever I'm aware of the state, such firewalls are called stateful inspection firewall. Application level firewalls act at application layer. Next generation firewall work on multiple layers, layer 3, layer 4, layer 4, layer 5, layer 7 also, right? So they have deep packet inspection capabilities. Packet filtering firewalls were very simple firewalls which would, inspect the source and destination. Right. Next question. So generally, this is my switch, and I'm sending. Uh, I have a legitimate IP, but I'm sending you false MAC addresses. Okay, first time I sent some MAC address, second time I sent some MAC address. So ARP had this issue, and that's called ARP poisoning, right? It's a very common, used to be a very common attack when our networks were not very secure, firmware were not secure, ARP tables were not secured by, uh, you know, proper IDS IPS solutions, because ARP as a protocol was a very simple protocol and it could be fooled very easily, right? So ARP poisoning is the answer, right? And then we come to the fifth domain in security, and that's the identity and access management. Now, identity and access management is a very core, problem statement of today's security issues, because it's all about identity and access. Ultimately, you want to deny access to the rogue elements, and you would like to have access very, very well defined in your organization, right? So when we look at identity and authentication, we look at what is the IAM life cycle. So you will have frequent changes in users, right? So there will be a life cycle. Our employee will be born in the organization, he'll work, he might get promoted, and he will have access privileges, and then his life cycle, he will go out of the organization. So you have to maintain a life cycle for identity and access management. Authentication factor: whenever identities, they access something, access an application, access a resource, you need to authenticate them, right? And then based on that, we give authorization. And there are three types of authentication measures. You call it something, that is generally we use password, but we would like to have a, a token or some kind of multi-factor authentication, which is, you call something you have. You receive OTP on your phone because you have your phone. That's called something you have. And finally, you might also give elevated privileges based on your biometric factors. That is something you are. So today, your phone you can trust because your phone trusts you by your biometric access. So these are multiple levels of authentication techniques. Most applications today would like to incorporate multi-factor authentication because a single form of authentication is not a secure arrangement. Uh, One of the major improvements in authentication has happened over a period of time, which is called the single sign-on. Right, single sign-on has been there for last, you know 8, 10 years, and single sign-on has been one of the major ways in which we handle today uh, access to applications. Now, the problem of single sign-ons happened when you had multiple applications and you had user who had now used to remember username password for each application separately, right? Now, if you have to do that, and if in your organization one employee uses 10 applications, what is the most common thing a user is going to do when he has to remember so many username and passwords? As a human, as a security professional, you tell me, what are you going to do if you had 10 applications and you had to keep create 10 username and passwords? What is it that you are going to do? I do that. I'll be honest. Let's be honest to each other, because that's a human weakness. What are you going to do if you used to have if you have to use 10 applications and you need to remember 10 usernames and passwords? Very right. Store them in a notepad. I will be more lazy. I'm much more lazy. I will create one complex password and put the same password in all the applications. Right? If you don't have an SSO, Raghu, if you don't have an SSO, what will be the human tendency? That I'm asking for the human weakness. Write it down as one, right? Like I have 3 or 4 bank accounts and I write down different passwords. A human tendency, I can't help it. Right? But in an enterprise, what will I do? In an enterprise, keep same password, right? That's our human nature. We will use the same username and password, even if you I am a security professional. I'll be honest with you. I can't remember 10 username and password. So what could be the first solution if you want to implement an SSO? What could be the first basic solution which organizations initially adopted? So what could be one first SSO solution which you can build to if you are an organization which doesn't want to spend too much of money? What could be one first very simple and a uh, you know good process to use? Okay. 802.1x is too technical. Yeah, but then again you'll have to implement. SAML is a more, of course, SAML is one of the technologies by which before SAML you don't have the money to implement the SAML architecture on all your ADFS. Yes, of course. Again, ADFS will use Kerberos. I will not go to technology. Simple. Give me a simple solution. Easiest and simplest. You don't have the money. Your management has said we don't have the money to implement SAML and SSO because all applications will now be has to be SAML compliant. A simple solution. Can someone give me a very simple solution? Can you have a password manager? Can I have a password manager? Of one of the most simplest solution. Where's the most cheapest solution? Right? You don't even need an active directory. How many organizations? I've never seen a small company having an active directory. 30, 50 organizations. Nobody uses active directory. Federated identities again will come. Federation of identities will come with SSO only. Right? I can use a very simple password manager. Okay. Right. Never think of complex solutions. It all depends on. Always think of solutions based on risk. Of course, password managers come with their own risks. They are also called password vaults. Vaults also come with their own risks. Vaults become a single point of failure. Right. So we always look for solutions based on risk. Always remember that. Okay. So this was just a risk based approach I wanted to tell. Kerberos is one of the major security techniques by which we protect single sign on ADFS. ADFS uses Kerberos in a very, and there are a lot of exploits now available on Kerberos. Right? Now, whenever we give access controls, there are access control models. We first saw access control models, right? KeyPass got hacked, LastPass got hacked, a lot of all these got hacked. But right, there are good solutions available which today come with MFA also. So your password manager comes with an MFA, and you have to touch your fingerprint and then only goes. Mac uses a completely password vault using a fingerprint manager, right? I use it very, and it's been 5 years I've been using Mac. Now I bought next Mac, pretty satisfied, right? So when we design access controls, the access control e- are designed based on certain key principles. There's something called discretionary access control model. Discretionary access control means that discretion lies on the owner. Owner decide who to give access to. Mandatory access controls based on labels and classifications. If I am a kernel, I have the authorization to use a secret file. So I carry a label of secret. I can only a major or a captain may not be able to access the confidential files. So when I was a commanding officer, I as a CEO could access secret files. Nobody else could. Role-based access control, one of the most common access control models deployed in enterprises. Based on roles, you grant access. So that is a role-based access control. We have attribute-based access controls. Depending upon a time, space, IP, we grant access, and that's called attribute-based access controls. And then we have rule-based access controls, which are generally deployed on firewalls. If this is the source IP, if this is the destination IP, then only allow the access, and that's called access control modeling. Right now, whenever you give access control, there is going to be the authorization. The access control is going to grant authorization, and authorization is granted based on principle of least privilege, separation of duties, need to know. Okay, and then we need to establish accountability so that subjects do not refuse their actions, and that's one of the major requirement. And therefore, to establish accountability in access control, what is it that we do to establish accountability? What process is followed, should be followed, so that subjects are held accountable for their actions as far as access control is concerned? That's the question. There's a term used for it. If you do logging, then what? Then after that, you've logged, then what? Audit. There is a typical kind of audit for access. What is it called? Term. So see, it's all about terms. In our real world, we might be doing something, but from the exam perspective, there's a typical term for it. We do logging, we do audits, but there's a typical term for access, which should form part of your access control policy. It's called a access review. Why do we do access review? To see that there is no privilege creep, there is no unauthorized access, right? So access review is the term which is used especially in terms to see that there is no unwanted access to your applications and solutions, right? Now, somebody said that for SSO, we need to have federation. Now, the federation of identity. A federation identity means one identity. Today we have organizations which are spread across all over the world. You might have an office in US, you might have an office in India, you might have an office in Dubai, and your user from US might want to access application in India, might want to access application in US. So one identity, can it be federated across three global organization space? And that's the world we are living in today. So therefore identity needs to be federated. How we do federation? Those are the technologies which are important. So one of the major ways in which do federation of the identity is SSO, right? So whenever we do federation, there is will be somebody called a identity provider, right? Today, Google and Microsoft are one of the major identity providers, right? Why? Because everybody has a Google account, everybody has a Microsoft account. Today, Google and Microsoft both provide you with personal accounts and enterprise accounts. So you can have enterprise identities and you can have personal identities. And using personal federated identities, you can log into multiple applications like LinkedIn, GitHub, Facebook, where Google becomes your identity provider. Similarly, today you can use Microsoft accounts if your most of the enterprise accounts are on Microsoft. So Microsoft can provide you with an organizational identity, and with that you can use SaaS based applications to log into, and that's called identity federation. And to manage, access levels, we use these days something called privileged access management solutions. So previous privileged access management solutions are solutions which keep account of all your privileged accounts, right? Because all applications have privileged access levels. So all hardwares have privileged access levels, or applications have privileged access levels, your cloud has privileged access levels. So PAM solutions manage all these privileged accounts and manage the access review of all these privileged accounts. Those are called PAM solutions. Now, today we also talk about something called just in time access. Now, just in time access is an access which is given for a short duration of time. It might so happen that a vendor needs access to your system, or a particular user needs access for a very, very short amount of time, right? That time you generate something called just in time access tokens. Generally, PAM solutions are capable, or IAM solutions are capable of generating just in time tokenized access. You access the application or hardware or a server resource for a specified amount of time, and automatically the access is revoked. Nobody has to keep track of whether who has access to what, and that's called just in time access. And we also use credential vaulting, as I told you, password managers for managing some kind of a single sign on. That's a good solution. If you don't have any single sign on solution, use a password vault, and that's a great solution, right? So this is broadly what identity and access management is looks like when you prepare for, and these are the core things. I'm touching core, there's a hell lot, right? There's a lot, but these are the core things which you must know for your CISSP, right? So let's do a few questions and then call it a day, and tomorrow we will do domain 6, domain 7, and domain 8. So keywords, right? Great. You guys have caught on the keywords. Whenever there are labels, I have to have mandatory access control. Very correct. Right. Okay. A user authenticated once to the corporate portal and now access email, HR system, and CRM without logging in again. This is an example of single sign-on or federated identity management, right? Multi-factor authentication is out, Kerberos is out. So, which is a bigger answer? Is SSO the bigger answer or federated identity management? So here we're talking about authentication. Single sign-on is an authentication technique. It's not an identity management technique, right? So therefore, single sign-on. Last question. Last question, or we have one more question? Yeah, last question. This is a slightly confusing question. Let's see. So maker checker. It's also called maker checker. So it's not least privilege. So least privilege is out. It's not split knowledge. Split knowledge is, unless I apply this key and you apply this key, two keys come together and then only I open. So split knowledge is not. So it could be either dual control or two personalities. It's not dual control. Dual control means two people have the control. It's not. So I'll go with B, right? Oh, it's C. I got wrong. Dual control requires two people to approve sensitive transactions. At times, even the instructor might go wrong, right? Two-person control requires physically present. All right. At times, even the instructor can go wrong. So that's all, guys. Uh, I finished day two, right? And tomorrow we will do domain 6, 7, and 8, right? This is a prelude to my March CISSP session, right? A target for Protect Academy we have aimed. We can see that in next 10 years, a decade or so, India will have at least 1 million, at least 1 lakh or 1/10 of a million CISSPs, and that's the mission. And we've been able to achieve great success, to be honest, in last 3 years of me conducting structured 2.5 years of structured training. Uh, Roughly 100, more than 100 people have appeared for the exam and passed it, and all those who have appeared in the exam have passed, right? So that's the confidence with which we come. And this is a prelude to those who are aspiring and want to see whether I'll be able to clear CISSP. I've heard it's very difficult. It requires a lot of effort. Of course, it requires a lot of effort. You don't achieve a gold standard without achieving a lot of effort, but that effort can be made more structured and easy to understand uh, with correct guidance and mentoring. And that's what I provide. That's what Protect Academy provide. And I hope you had a great learning session. I love teaching. I got my passion for teaching when I was in the army. I was made instructor, and from there today, I carry that passion for teaching. Thank you so much for joining. All of you have been a great help. You've been consistent since yesterday and today, and we will start with domain 6, 7, and 8 tomorrow, and we'll try to finish it. So that will give a close for our quarterly session for those who want to do CISSP and get that knowledge. It's very great to get that knowledge, right? Thank you so much, and details are there if you would like to enroll on the course. It starts, I think, second week of March, and day one recording is there on my profile. If you have not gone through it, the day one recording is already in the profile and on the YouTube channel, right? Thank you so much, and see you next time. Yes, Anand.